Welcome to Cookie's Maths and Science Hub. Today we'll be looking at balancing chemical equations. So what is a chemical equation or a chemical reaction? Well, in a chemical equation, we have one or more reactants, that is the things on the left-hand side of the arrow, yielding one or more products, that is the things on the right-hand side of the arrow. This might be through adding two chemicals together, which is usually the most common case, but it can also be from simply one element decomposing or going through other changes that we can record in these equations. Looking at an equation here, we've got 2NaOH plus H2SO4 gives Na2SO4 plus 2H2O. Now, we'll have another video coming out soon about naming structures such as these, but for now, we're just going to look at the balancing. So let's look at two important parts of that. We have the subscripts, which are the numbers, the little numbers underneath the letters, and we have the coefficients, which are the larger numbers in front of the letters. Before getting into some practice examples and looking at balancing equations, let's consider the law of conservation of mass. The law of conservation of mass states that matter cannot be created or destroyed. In other words, the number and type of atoms going into a chemical reaction, or our reactants, must be the same as the number and type of atoms coming out of that chemical equation. So our mass in is the same as our mass out, or whatever goes in is the same as what comes out of the equation. If an equation obeys the law of conservation, it is considered balanced. Before we get into some real examples, let's look at a basic template. So we know whatever goes into the reaction must be present on the other side. The same amount must be present on both sides. Now, we need to be careful, and this comes back to those two numbers I talked about. Remembering coefficients are our numbers in front of the letters, and subscripts are the numbers beneath the letters. We can only change the coefficients when we're balancing a chemical equation. We're not allowed to change the subscript. So looking at this example here that we have A3 plus B2 gives AB. Now we can see straight away if we write out our reactants and products, which I think is the best way of balancing equations. Sometimes it takes a bit of time, but it's really clear and concise, and it allows you to see what you have on each side. So in our reactants, we have A 3 times, and we have B twice. In our products, we have A once, and we have B once. Now, whatever number we put in front of that AB to balance it is going to change both of them. So we need to be careful, because we can't just change the subscripts, or the little numbers next to the letters. So, given that we want that to balance with the left-hand side, we may have to do some multiple steps. Because if I was to put a 3 next to AB, that's not going to actually fix this for us, as our B still wouldn't be balanced. So let's look at our two numbers, 2 and 3. What do 2 and 3 both go into? That's right, 6. So if we put a 6 in front of our AB, let's see what happens there. Okay. Now we can see we have 6A on the right-hand side and 6B on the right-hand side. So what might we do to the left-hand side to balance this out? Well, again, we can't change the subscripts, so we can't just cross those 3 and 2 out and change them to 6 and 6. So what can we put in front of A to make it so it is 6? Well, okay, can we just put a 6 in front? No, you have to be careful because it multiplies the subscripts. So what multiplied by 3 gives 6? Well, in this case, it'll be 2. So 2, if I put that in front of the A, will give us 2A3. And then for the B, same sort of principle. What multiplied by 2 gives 6? In this case, it's going to be 3. Now, if we look at our little table of products and reactants, we can see in our reactants we have 6 A's and 6 B's, and in our products we have 6 A's and 6 B's. This means our equation is balanced, as we have the same on the left-hand side as we do on the right, or our mass in is the same as our mass out. Let's look at some real-life examples now, using some actual chemicals and a few more steps that will be involved. Before going any further, let's establish some rules we can apply to every scenario. So we know from our law of conservation of mass, matter cannot be created or destroyed. Subscripts, those are those little numbers next to the letters, cannot be added, removed, or changed. You can only change the coefficients. Coefficients can only ever go in front of chemical formulas, never in the middle of the formula. When balancing, an easy way to make it so you have to do less corrections is to first balance the metals, remembering the metals are on our left-hand side of the periodic table. Then balance the non-metals, so they're on the right-hand side of the periodic table, excluding hydrogen and oxygen. Then balance hydrogen, followed by oxygen. Doing these steps in this order means that you'll avoid having to go back and correct yourself in a lot of balancing. So, think you're ready to have a go at some? Let's have a try, shall we? If you're feeling confident at this point, pause the video here and have a go for yourself before we go through it. So, in this case, we have CH4, also known as methane, but again, let's not stress about the names right now, plus oxygen, or O2, gives CO2, carbon dioxide, plus H2O. And I'd hope you'd be able to see H2O is water. So, writing out our reactants and products, our reactants, we have 1 carbon, we have 4 hydrogens, and we have 2 oxygens. Now, I usually write these out in the order I'll balance them, as it's easier to just work down the list. In our products, we have 1 carbon, we have 2 hydrogens, and we have 3 oxygens. So, the first step when balancing an equation is to balance the metals. In this case, carbon is a metal, but it's already balanced. So let's move down into our non-metals, which there aren't any present besides hydrogen and oxygen. So then we move into hydrogen. So, we have 4 hydrogens on the left-hand side, and 2 on the right-hand side, only present in that H2O. What number do you think we can put in front of H2O to make our hydrogens 4 on the right-hand side? If you said 2, that's correct. If not, don't stress, you're here to learn. So, we put 2 in front because remember, when we put coefficients in front of our chemical formulas, they multiply the subscripts. So if we put a 2 in front of H2, that means there's 4 hydrogens now present. With the 2 in front of our H2O, you have to be careful that you also multiply those oxygens, as anything that 2 is in front of is multiplied. So now we have on the right-hand side 1 carbon, so that's balanced because we have 1 carbon on the left. We have 4 hydrogens, that's balanced because we have 4 hydrogens on the left. And we have 4 oxygens, which isn't quite balanced. So looking back at our left, we have 2 oxygens. So all we need to do in this case is put a 2 in front of our O2. This is why we balance oxygen last, as it's often by itself in equations, meaning it's quite easy to balance as the final step. And once more, you have a balanced equation. We have the same number of carbons on each side, the same number of hydrogens, and the same number of oxygens. We've only changed the coefficients, and we can see that the mass in is the same as the mass out. Okay, I'd strongly encourage you to pause now and have a go at this one yourself before you go any further. Okay, let's have a look, shall we? We write down our reactants and products. That always helps us out. So we've got our reactants, we have 2 silver on the left, and we have 1 silver on the right. Again, don't stress if you don't know all the names right now. They are on your periodic table, which hopefully you do have in your chemistry class. But, as I said, we'll look at naming in another video. So we have Ag, 2 on the left, Ag, 1 on the right. We have 1 oxygen on the left, and we have 2 oxygens on the right. So, first things first, let's balance our metals. We know Ag is a metal because it's on that left-hand side of the periodic table, next to that staircase. So, if we have 2 on the left and 1 on the right, all we need to do in this case is put a 2 in front of that Ag on the right-hand side. Now our silver is balanced, or our Ag is balanced. Let's look at our oxygen. So we have 1 on the left and 2 on the right. Oh, seems straightforward enough. We'll just put a 2 in front of it on the left. However, in this case, it's attached or in a compound with that Ag, meaning the only place we can put a 2 is in front of that whole compound, the whole chemical formula, meaning we have to put a 2 in front of Ag2O. Let's do that now and see what happens, because that will balance out our oxygens, and it's the next step. You can see now in this step, we've balanced out our oxygens, but we've actually unbalanced our silver or our Ag once more. Don't fret if this happens, it is quite common, and you do have to go back and forth sometimes with these equations, changing the numbers and coefficients. So, we now have 2 oxygens on the left, 2 oxygens on the right, perfect, balanced. However, we have 4 Ag or 4 silver on the left and 2 silver on the right. So, all we need to do is look back on that right-hand side and change that 2 that we put before to a 4, as that'll make sure that we have the same amount of Ag on either side. Once more, we have a balanced equation. You can see that one, whilst pretty straightforward and not too many things to balance, did require multiple steps. So you do need to be careful about making sure that you keep things balanced and you're not changing them if you go and balance other things, as it can happen quite often. Okay, the next one we're going to look at is a really challenging one, and it's got a lot of steps. See how you go with it. If you want to pause, that's fine. Otherwise, we'll have a big chat through it and we'll take the many steps that we need to do to balance the equation. So without further ado, let's have a look. Already, you can see there's lots of parts here, so we do need to be careful. The only hint I'll give you is it's the exact same process as the ones we've already done. You just make sure you write out the reactants and the products, which I've done here for you, so you can see what you have on either side, and work through your metals, then your non-metals, then your hydrogens, then your oxygens. There'll be multiple steps going back and forward. Pause it right now and see how you go. Make sure you have a notepad and pen because you need to make sure you're writing these down. You're not going to be able to do it all in your head. Okay, should be enough time to figure it out, hopefully if you paused and didn't just let the audio play. So, we have one copper on each side, or Cu in this case. Again, want to reiterate, we're not worried about the names in this video, so don't stress if you don't know all the names for everything. It's just how I refer to them, but I will refer to them as their letters as well. So we have Cu on the left and Cu on the right. We have one of each, balanced. Don't need to worry about it, it's done. We then have one nitrogen on the left, and we have 3 nitrogens on the right. Now, be careful with this one, because you can see we have nitrogen and an oxygen, or NO3, in brackets. When we have those brackets like that, that 2 means we have 2 nitrogens, and in this case, 2 times 3 oxygens. So we'd have 6 oxygens just in that bracket there. So because we have 3, we have 2 in that bracket, and then we have 1 later in the equation as well, in the NO, or the no, later in the equation. For our hydrogens, we have 1 on the left and 2 on the right. And for our oxygens, we have 3 on the left and 8 on the right. Again, we have 6 in that bracket bit because we have 2 times 3. Then we have 1 in the NO and 1 in our H2O. So, we've done our metals. Our metals are balanced. So let's look at our non-metals, in this case, nitrogen. So, we have 1 nitrogen on the left and 3 on the right. So, we will put a 3 on the nitrogen on the left, or the N on the left-hand side of our equation. Again, similar to our last example, that N is mixed up with a H and an O, so we can't just put the 3 in the middle of it, we have to put the 3 on the left-hand side, meaning we'll have to multiply everything. Let's see what that does to our overall equation. Okay, so once again, listing out our reactants and products with the 3 now in front, we have 1 copper, that hasn't changed, good, means we don't have to worry about it. Now we have 3 nitrogens, tick, it's balanced, awesome, we don't have to worry about it. Now we have 3 hydrogens and 2 hydrogens on the other side. Already that's going to cause us some issues, but let's see what happens. Then we have oxygen 9 and oxygen 8 on the other side, or O9, O8 on the other side. So, just to reiterate those names again, guys, Cu is copper, N is nitrogen, H is hydrogen, and O is oxygen, just in case I go back and forth on how I'm referring to them. So, our next step in an equation like this is to try and balance our hydrogens out. Now, we can't really use fractions at this point. You'll be able to do that in more advanced studies. But for now, we really need to get that hydrogen to be an even number. So let's look at our hydrogens on the right. And for this sake of this, let's put a 2 in front of that hydrogen and see what happens. So now we have 4 hydrogens on the right. And we've also changed our oxygens. You'll see that actually balanced our oxygens as well, which is quite convenient for the time being. But we still have that 3 on the left-hand side. So we need to balance our hydrogens on the left-hand side now. So we're going to swap that 3 we put down before and put a 4. Now, like I said, this is quite a complex one, so there's going to be lots of steps back and forth correcting different things. Awesome, look at that. Now our hydrogens are balanced. But we're stuck again because we've unbalanced our nitrogens, which is always fun. So what can we do to balance our nitrogens out again without interfering with those 2 we've just changed? Well, we have the NO on the right-hand side by itself, and that's where we're going to need to have more N. So if I put a 2 in front of that N, it's going to increase it by 1. Remembering if there's no number in front, it's just a valid 1. It just starts as 1. So if I put a 2 there, let's see what effect that has on our equation. Fantastic. Now our nitrogens are balanced again, and so are our hydrogens. Now, looking at our oxygens, because everything else is balanced, we just need to balance our oxygens. We have 12 on the left, and we have 10 on the right. Now, there's 2 places we could balance our oxygens. We could balance them in the CuNO3 2 bit, or we could balance them in the H2O bit, or we could also balance them in the NO bit. But we have to be careful here because we really want to try and avoid unbalancing everything else. Now, we know when we put that 2 in front of the H2O, we had to change what it was on the left-hand side. However, Given we're working with even numbers, what we can do is simply double that and then look at how that will affect things and have a bit of a play. So let's change that 2 for right now in front of the water, or the H2O, to be a 4 and see what happens. Fantastic, we've balanced our oxygens, but wait, yet again, we've unbalanced something else. So this time we've unbalanced our hydrogens. So to balance our hydrogens on the left-hand side, we're going to have to double that 4 because that's the only place the hydrogens are. So let's double that 4 and see how that affects our equation. Fantastic. Once again, we fixed our hydrogens, but we've broken our oxygens and nitrogens. We're really going around in circles with this one. So we need to balance our nitrogens and our oxygens, and we need to try and do it simultaneously so that we can avoid going back and forth the whole time. So looking on the right-hand side, where we're going to need to balance these, because we have less N and O on that side, where can we balance N and O together? Well, it's either in the CuNO3 2-bit or the NO bit. However, look at what we have on the left. We have 8 nitrogens and 24 oxygens. That means we're going to need a lot more oxygens than we are nitrogens. So unfortunately, as much as we've tried to avoid it, we're going to have to use the CuNO3 2 portion because that's where more oxygens are. Now, we have 6 oxygens in that section. And if we look at the rest of our equation, we have 6 oxygens. 2 from the NO because we've put a 2 in front, and 4 from H2O because the 4's in front. 2 plus 4 is 6. So that means we need an additional 18 oxygens to balance out our oxygens. So let's look at how many oxygens we have in CuNO3 2. Well, we have 3 in the brackets, but then we multiply that by 2. So we have 6. So how do we get to 18 from 6? What do we multiply 6 by? 3. So let's stick a 3 in front and see how that fixes, and see if it hopefully fixes some of our other nitrogens and stuff like that as well. Look at that. We've got balanced nitrogens, balanced hydrogens, and balanced oxygens. Our N is 8 on the left, our N is 8 on the right. Our H is 8 on the left, our H is 8 on the right, and our oxygen's 24 on the left, and our oxygen's 24 on the right. But we've unbalanced our copper, or our Cu. So we have 3 on the right and 1 on the left. Thankfully, hopefully you can see this is an easy fix just by putting 3 in front of the Cu on the left-hand side. Woof! It took a fair while and a bit of work, but we got there. Everything is balanced. The mass going into the equation is the same as the mass coming out. Everything that's on the left-hand side is the same on the right-hand side. Now, I want to really go into this again, guys. That's a really complex balancing equation. You really won't need to do many that hard in levels 3, 4 at college in Tasmania or in Australia around that level, and you won't have many similar in the high school level either. Definitely not. Most of the time you'll be balancing with just a few numbers here or there, maybe one change back or so, but nothing this complicated. So if you could do that, fantastic. You're all over balancing equations. If you couldn't, don't stress. A bit more practice and keep working on it, and hopefully one day you'll be able to do these more complex ones, but hopefully you'll be far further into your studies by then as well. Thanks for watching. Hopefully now you have a good idea of how to balance chemical equations, both simple ones and more complex ones. Be sure to like, share and subscribe, and check out our other videos on maths and science topics. Hope to see you again soon.